Today what we are going to start with, we'll start with something called types of applications. Now you understood what is SAP application, what is R3, what is BI, what is NetWeaver, what is its functions, all these things you understood now. So now next what we are going to start is, what are the different types of applications that we are going to use. So when you speak about types of applications, applications are generally categorized into two categories. What are the two categories? Like one is OLTP and other one is, what are the things now? One is OLTP and other one is what? OLAP. So when you speak about OLTP, what is OLTP is like? Online transaction processing, and OLAP stands for what? Online analytical processing. So any idea about these two? Any idea what is OLTP and what is OLAP? Heard about them? OLAP is for reporting, OLTP is for transaction purpose. You know, the guy sitting beside me is saying, right? OLTP is for transaction purpose, OLAP is for reporting purpose. What is the main difference between these two? The name itself indicates online transaction processing. That means you are going to process your transactions. Transactions what? Online. So what exactly OLTP type of application? See where exactly you are going to use OLTP type of application is. See now, as soon as the business happens, as soon as the business takes place, let us say, now what is that my requirement now? This data has to be updated immediately into the database. As soon as the business takes place, this data has to be what? Updated immediately into the database. So in this case what we do? We use OLTP type of application. So in this case we are going to use OLTP type of as and when the business happens, now data has to get updated immediately into the database. So then you are going to use what? OLTP type of application. So why data has to be updated immediately into the database? What happens if the data is not updating immediately? Is it something to do with decision making? No. It's nothing to do with decision making. What's the main thing? Okay. Let us say it is updating after 15 minutes. Imagine, you went to an ATM and withdrawn some money. Let us say it is updating after 15 minutes. Meanwhile, what you can do? Meanwhile, what I can do? Again, I can go to a bank or somewhere again withdraw the money. That means if the data is not updating immediately, is there any chance of online? What is the main concept of application? What is it? Centralization of data, so that I can access it from anywhere. Now, centralization is possible only when your data is getting updated when? Immediately. What is that now? Main thing. This online is possible only when your data is getting. That's what. No? So, as and when the business happens, let us say immediately it has to be updated into the database. In those cases, you are going to use OLTP type of application. Now, let us say your banking application, or telecom sector, or reservation sector, anything that is the application which you are using to carry out your business is always what? A OLTP type of application. You can observe as a non when you do any transaction, their data is getting updated immediately or not. So even same way, your SAP R3 is also a business related application. So R3 is what now? It's a OLTP type of application. So that's why when you look at R3 system, right? As and when the business happens, it just gets updated immediately into the database. Like suppose, imagine I am creating one sales order, or imagine I am creating a delivery document, I am developing a billing document, right? We are creating a purchase order, bill of materials, or any transaction. So just what happens now? It gets updated immediately. So now what is the main primary operation of OLTP type of application is what? The primary operation here is to what? Update the data into the database, and that to what? Immediately. Understand now? The main purpose of using OLTP is to update your data into database. But when it comes to OLAP, the primary operation in OLAP is to analyze the data. Understand now? Online analytical processing. So I need to analyze the data. Is there any data in OLAP to analyze? Where is data is updating now? Into OLTP. So that means that's why you are extracting the data from OLTP to where? OLAP. So clear now why? Because updation takes place in OLTP. But when you want to analyze, so there is no data in OLAP to analyze. So what you are going to do now? You are extracting your data from OLTP to. So now when it comes to your BI, so BI is what now? It's a OLAP type of application. So that's why we are extracting our data from SAP R3 to BI side. Clear? The logic is clear. What is OLTP and what is? Now, in application sense, what does a transaction means? Whenever you take any application, what exactly a transaction means? So whenever you interact with the database, whenever you update some data to the database, that we call it as a transaction. So for OLTP, what is a transaction now? What does a transaction means? When data is updating here, when you are extracting. So for OLAP transaction means extraction, for OLTP transaction means business. Clear the logic now? Right. Clear, the main difference is clear now. One is for updation purpose, other one is for OLAP is for what? Analysis purpose. Done. Next one is called, what is the difference I am going to show you is like relevance of data. What is that now? Relevance of data. So when we say relevance of data, any point of time, consider the data in the database. What type of data is available in the database? What is the relevance of data with respect to database? That means that is called as relevance of data. Now, any point of time you consider the data in OLTP, what type of data is available there? Is it present or is it past or is it historical? Right, suppose, imagine, consider like this. Let us say now the time, imagine in R3, now what is the time saying? 8 o'clock. So now, imagine at 8 o'clock how many records I have here? Let us say I have in a table, I have totally 1000 records are stored. Okay. Now, let us say this is my first time, still I have not started any extraction. Imagine, if you consider the data at 8 o'clock here, how much data is there in BI now? Still I didn't do any extraction. So what is the data that is present now, right now? It is. So if you are considering the data at 8 o'clock, here it is 1000, there it is. Suppose imagine I extracted the data, so let us say how many records are coming in? 1000. Now this data here also 1000 and OLAP is also let us say 1000. Now, fine. Now let us say some business is happening at 8.5. Some business is happening at, so when it gets updates into OLTP, immediately, right, when it is going to getting update to OLTP now, right, immediately, right, that means what? Let us say some 5 transactions are happening at 8.5, so let us say 5 records gets updated at. Now, if you look at data at 8.5, what is the data here now? 1000. When I consider the data at 8.5, what is its relevance? But when you consider your data in OLAP at 8.5, still I didn't do any extraction. Still it is 1000 only. Now, what is its relevance now? It is, what is the, as I said, present. But here it is still the past until the last extraction what has happened. Only you have data up to. Understand now? So when you think about relevance of data, what is it now? It is always, here it is, current. Up to that point of time, whatever the business is happened, that particular data is available here. But when you speak about relevance here, what is that? It is historical. Clear? Any doubts to this? Relevance is clear? No. Come to the other part of relevance. Let me speak about something like updation of data to the database. Updation of data to the database. What is the frequency? What is the frequency? Updation of data to the, is it updating more frequently or, so business may take place every minute? That means every minute data is keep on updating into the database or not? So now, here what is that now frequency now? It is more frequently. If business is not a one-time activity, business is a continuous activity. What is going to happen now? What is happening? Every minute or every 5 minutes or as soon as business is happening, it is getting updated. So that means data is keep on updating into the database. So number of users are how many? End users, business purpose. Let us say banking itself. Who are all the end users? Everyone who has the account will do a transaction. So how many number of users are there? That's what, right? So that is what now? Data to the database takes place more frequently. Now, here. So here what happens? Do I extract data every minute? I don't extract data every minute. It depends upon my requirement. So let us say I want to imagine a report every 1 hour. Is there any requirement to extract every data every minute? I will be extracting the data hourly once. So that means, let us say, what is that now? 8 o'clock I have extracted. Now between 8 to 9, let us say every minute one transaction is happening. That means between 8 to 9, let us say how many records now? 60 records. That means every minute data is updating. Now what I'll do? At 9 o'clock I'll be extracting one shot. What is the business that is happening from 8 to 9? So that means, so here what happens now? It is less frequently. Updation of data to the database takes place less. Right. Next. So next is like amount of data per transaction. Right. Amount of data for every transaction that takes place. How much of amount of data is storing into the database? What is transaction means? Is it the business? One transaction? Is it one record or one transaction, one record? No? So let us say it is very small amount of data, right? But here, when you speak about here, okay? Now here what happens? One shot, how many records you are updating now? So that is a huge amount of data, right? So suppose you have millions records means, suppose you have million records, what you will do? One shot, all the million records you are going to update it or not? So here, number of transactions are more, but updation of data to the database is very small. But here, number of transactions are less, but for every transaction, so like that, set of transactions that are happening into OLTP, let us say R3, this entire data, one shot, we are extracting it to BI. Collection of transactions, one shot we are extracting it to, understand the logic now? What is OLTP and what is OLAP? Done. Okay? So next, what you will say, data in the database. So data in the, so this we call it as normalized. Then this you call it as denormalized. So you will understand what is normalized and what is denormalized when we will go with the next concept called database designs. Next we are going to discuss something called as database designs. There you will understand what is normalized and what is denormalized. Okay? Right. Then what is that now here? As I said, number of users. Who is the end user here? How many number of end users? Just now I said, let us say, yes, so you imagine a banking application. So everyone who has an account, the same way R3, the one who is dealing with the business, right? It may be, it's what? It's more number of end users. But here what? Who is the end user here? What are the reports that you are developing? Is used by the top level people. So how many top level people? A very few, right? So it's a clear? Done. Next, level of analysis. So here we call it as less, here you call it as high. You will understand this also when I go with database designs concept. Clear what is OLTP and what is OLAP? The people sitting in front of me, is it clear? Yeah? How about you, Vinay? This mic is not working. Yeah, fine. So, the types of applications you understood? Fine. So, next, we'll come to know a concept related to BI, wherein you understand now how your extraction process takes place. Extraction takes place. Are you going to extract the data every minute? Or every 1 hour? Or how much of data that you are going to extract that we are going to discuss right now. So, extraction process. No, when you speak about extraction process, first you have to decide something called, even if you define something called as, right, we are going to define some definition called update mode. So, update mode is a parameter. Update mode is what? It is a parameter which has to be set. Okay, update mode is one setting. It is one parameter, a setting which you have to be, which has to be, that means this setting you have to select. Parameter means what? Some setting you have to select, which has to be set before extracting the data to, what? Before extracting the data to BI, which defines what? See, which defines what amount of, data has to be extracted from where? From source. Do you want to extract entire data from source? Or do you want to extract only a particular part of it? That is defined by what? That means before extracting the data to the BI, you have to select some setting called as update mode. According to what update mode you are selecting, that particular data will be extracted from your source. Now, as you said, the first very important point understood is extraction is a one-time activity. Is extraction is a one-time task? You are extracting the data only one time? No, extraction is not a one-time activity because today I have extracted. Again after today some business keep on getting updated in the database. So now that means what is it now? You have to extract the data not one time, it has to be a continuous task. So in update modes, there are different types of update modes are there. Okay, let us check types of update modes. Now the first one being called, what is that now? Full update. Okay, what is that first one is called? Full update. Second one is called initial update. And third one is called delta update. A full, initial and delta. Okay? Now, see now, what is that now? So let us say, imagine this is your R3, just now as we discussed. And let us say this is your BI. Now, let us consider just now example what we discussed. Imagine at 8 o'clock. Here, how many records I have? 1000 records. Now, I am extracting now data for the first time. We are extracting the data now, right now for the. Now, how many records it has to be extracted now? All the 1000 records or not? So now, at 8 o'clock, I am extracting my data. That means it has to extract now all the. So what is the logic? Any point of time, data in the R3 and data in BI should be similar. When you want to analyze, what is the business that is happening you are analyzing? Right, so now, that means, what is your now, see this, what is that update now? This is what is called. So when you use your update mode as full update, when you use your update mode as full update, and if you extract the data, what it is going to do now? It is going to extract now. It is going to extract now entire data from the source to the destination. So what is full update now? See? Okay, whenever we use update mode as what? Full update, and once we extract the data to BI, what happens? It extracts the entire data from source to target. Okay, what is full update is going to do is, alright, it is going to extract now entire data from source to the target. So, whenever we use the update mode as full update, and once we extract the data, it's going to extract now entire data from source to target. So, what is full update now? Right. Next. Let us say, imagine at 8.5, some new business is happening. Now at 8.5, what happens? Out of 1000 records, let us say one transaction has been modified. It's not a new transaction, it's a modified. Let us say, imagine at 8 o'clock, first let us say, imagine I have ordered for, let us say sales order. As a customer, I have ordered for the enterprise saying, right, this item I want this much of quantity. Let us say 100 units. So I have given order number now. Let us say order number is 1, item number 10. How many units I need to deliver? 100. So later on, I have changed my mind. I will say, I don't want 100 units, I want 150 units. Now what is that now order number is? 1 only. But quantity has been changed from 100 to 1. That means some change in the business. Earlier existing transaction is there, that has been modified. That's why I am saying it is a modified record. And let us say one new transaction has happened. So now, what time it is happening now? So that means when it is getting updated into the database? R3. It's a OLTP, so it is getting updated immediately into the database or not? Understand now? So that means at 8.5 if you consider your data here, at 8.5 if you consider the data here, what is the data that you have? 1001. So one modified record will be replacing the value in the 1000 itself. And one more new transaction. Now, but if you consider the data at 8.5, where in BI, still it is what now? Still it is? I have not yet done any extraction. Still it is That is what is the relevance what we have seen. So this is current, this is historical. Clear? Now what is that requirement now? Can I extract now data 85? Let us say every minute business is happening. Can you extract the data every minute? Now I don't want unnecessarily to put load on the live system. Let us say I am giving some, we are giving some time gap. So let us say I am giving a time gap of how much time now? 1 hour. So let us say between 8 to 9, imagine what has been done. Out of 1000, 10 records has been modified and 10 records has been modified and 10 has been newly added. Now, what is the amount of data at 9 o'clock here? 1010. It is 1010, right? So give me 1 minute. Okay? Right. So at 9 o'clock, now what is the amount of data now? It is 1010, right? Now, what I am doing, I am going to extract my data at what time now? At what time? Now, when we extract data at 9 o'clock, how many records should I extract? Suppose, if at 9 o'clock also, imagine, what is that now? I am selecting what? What we are selecting now? Full update. So how many records is going to extract? What is the data at now? 1000. At 9 o'clock data in the source is 1010. When you use 9 o'clock full update, what happens? It extracts all the entire data. Na? So now what happens? At this particular point time, data is also now, the changes will reflect there. What happens here? It will also become. But is there any requirement to extract all the 1010? Now let us say, imagine I have 1 million records. Let us say for extracting 1 million records, imagine it is taking 1 hour. By the time you finish extracting 1 million records again, your load starts. Can I extract now all the 1 million records? What about the load on live system? Is it recommended now? So that means when I am extracting now data at 9 o'clock, do I need to extract all that 1010? So how many records should I extract now? So 10, which updated? What are the records I need to extract now? 20 records I need to extract, the 10 modified. What are the changes that has been done? 990 records are same. No need to extract because already these 990 records are, but the 10 transactions has been changed. Now the change has to reflect in the BI side also. So that means 10 modified records I need to extract and 10. That means when I am extracting the data at 9 o'clock, I need to extract only this 20 records. What are the 20 records now? Modified and now that means out of 1010, system has to pull how many records now? Only 20. But how does the system understand which 20 records it has to extract? How does the system understand which 20 records it has to extract? At least forget about the system. Let us speak about yourself. How you can say it is a modified or a newly added record? When we compare this 1010 to 1000, can I say it is a modified or a newly added? That means you are making this as your base point, a reference point to understand whether it is a modified or newly added. Same way, system also has to make it a reference point. So that it can extract the data only after the point that has been updated. So that's why what you are going to do, first time we are not using what? Full update. What we are going to use? Initial update. So full update, initial update both being same. Full update, how many records it is extracting now? Full update, how many records is extracting? Same way initial update also extracts what? All the 1000 records. But once initial update is successful, what happens? It will put some pointer on the system saying this was the last time extraction has. Let us say what is it is maintaining? Year 2011. Then let us say month. And let us say date. Then hours, minutes, and what? Seconds. Year, month, date, hours, minutes, and that we generally let we call it as a timestamp. Now what happens on the source? It will put a pointer, reference point, saying this was the time the last extraction has happened. Understand? Maintained. Clear? Now at 9 o'clock, what I am doing? Let us say we are running. What is that now? What is that we are using? Delta update. So now when I use delta update, okay. Now after this point, what is the data that is updated to the database now? After the pointer, what is the data updated? How many records gone to this database? 10 plus 10. Totally 10 records are updated. So after this pointer, what is the records that is updated into the database now? The 10 modified and 10 newly added records will be extracted. And once your extraction is finished at 9 o'clock, what happens? This was your pointer, right? So this pointer shifts from this point to this pointer, saying that last extraction has happened at 9 o'clock. Understand now? So now how is your extraction process basically? First time you are going to use initial update, that we call it as initialization. Once initialization is successful, next time onwards only you are extracting the updated records. That is what is your delta update. Clear now? So now what is that now? Full update is your seen. Then what is that next one is? Initial update is what? Same as what? But it will maintain a pointer, a reference. Okay? Now, next what you are doing? So, delta update what happens? Compared to the pointer, okay? Right? What happens after the pointer? Whatever it is maintained, right? It will extract only updations. It will extract only what? Updations means the modified and newly added records compared to the previous load has been extracted when you use what? The delta update. So what it will do, delta update, let us say, it extracts only modified and what? Newly added records compared to what? Previous load. Now, these modified and newly added records compared to the previous load, so they are called as Okay, they are called as what? LUWs. They are called as what? LUWs. LUWs means logical unit of works. So what are logical unit of works is like? Right? So the modified and newly added records compared to the previous load. So they are called as what? So that means whenever you use delta update, it is extracting what? It is extracting only LUWs. Clear? So whenever you use delta update, it extracts only LUWs. That is logical unit of works. First time you extract entire data, that is initialization. Next time onwards it is always what? Delta update. Clear? The point is clear. What is initialization? What is delta load? Now, when you use full update, what is the use of? Now let us say how did initialization? The reference point has been maintained. Now let us say after some time there is some mismatch of data occurred in the BI side. Let us say we have cleaned up some data in the, some problem occurred, we lost some data in the BI side. Then what you can do? Already the pointer is there, just I need to fetch my data, then I can use full update. Or let us say, imagine if you are extracting data from a file. Let us say I am extracting data from a. Now 8 o'clock I am getting a file 1, which has how many records now? The 1000 records. 8 o'clock I am getting file 1, which has how many records? The 1000 records are there in that particular file. Now 9 o'clock you are getting 20 records. Will it be coming in the same file 1 or file 2? Every time you will get a new file, right? Let us say file 2 coming. How many records are there in file 2? Only 20 records. It's not 1010. It is only having only. That means when you extract now from file 2, how many records do you want to extract now? All the 20 records are not. That is full update. If it is extracting from file, it is always full update only. But if you are extracting from any other live system or source, what happens now? What happens now? Right? So what is it now? First time is initial update and next time is always delta update. So in the implementation time, you make sure that your initialization is successful. Once initialization is successful, now I have my info packages and DTPs are ready. So there what is that I am selecting now? The delta option, and this will be keep on running. Supporting project, what happens? It's automatically scheduled with delta update. You'll be just monitoring whether it is successfully running or not. So first time do the initialization, next time onwards only the updations you are going to extract, so that data in both will be same. And here I have given a time gap of 1 hour. Here I have given a time gap of. So this time gap purely depends on end users reporting requirements. Suppose if the end user wanted a report, daily once, is there any requirement to extract the data every 1 hour? Or something like you have hourly report. That means I want a report every 1 hour. So that means what I have to do now? I need to extract the data every, so that the updations are also available for the reporting purpose. So like that I have hourly report. So when you say hourly report, my load should be a hourly load. Now let us say if it is a daily report, that means time gap should be once a day. So that is a daily load. So like hourly report, daily report, weekly, monthly, half-yearly reports, quarterly reports. So based upon that, your load also like hourly load, daily load, monthly load, weekly load, whatever it is. Understood now? Right? So that is how your extraction takes place. Any doubts with this update mode concept? Hmm. Okay. So that's what on the table, in the source table, it will maintain a pointer saying this is the time data has updated on this table, extracted from this table. Now, you have a time now. What time extracted is clear. Then, when you are loading also, system will maintain some timing. What time data is going, all those things in a source. It will have its own, system is smart enough to understand all those things. So after this pointer, what is the data is going and storing into the database now? In that particular table? 20 records. Hmm. Yes. Hmm. That what? That modified records also it is extracted. When modifications has been extracted, there also the change will reflect or not. That's it, very simple. 1 second. Yeah. So this pointers, if you want to check, in R3 side you have to go with a T code called RSA7. That is called delta Q. So that and all we are going to see when we start the R3 extraction part. What happened? So to check the pointer, you have to go with RSA7. At this point, you can better understand, I think, when I go with R3 extraction. How a pointer will be there, I will represent. Okay? Alright, so then we'll see how it is pulling that. Then we'll see where it is updating. All those things will be. So now usually how in R3 it will be configured. So first time you are extracting, you will extract from some place. Then what happens after the first time extraction, what has been happened, what is the data is storing in the tables will be pushed into some other part. That means delta extraction will be some other, extracting the data from some other place. Initial extraction will be extraction from some other place. That and all you understand when we go with R3 extraction part. It's not a table, we call it as a delta Q. So the pointer will be maintained on the table from where you are extracting. Shall we go further? Still some doubt? Hello? Vinay? Extraction process, what is the types of applications, everything is clear. So next, we are moving on to the important concepts called database design. Okay, database design. Now when you say database design, what exactly database design, what we are going to discuss here is, now when you look at the data in the server system, you have a client and you have a backend. That means when I say database design, when you are looking in the server, in the database, how exactly your data is storing in the server, how exactly your data is storing in the database, how it is looking in the back end, not how you see in the front end. It is how it is storing in the back end, how data is storing in the back end. Understand? No? So when we say database design, what does that mean is how exactly data is storing in the server system. When you look at the server system, how it is, not how it is in the front end. Now, first what we are seeing, first we are going to start with understand the database design of R3. How exactly data stores in the R3 database. Okay, then we'll come to BI. Okay, Vinay, I think you may be aware of this, but be patient. Just the guys who are sitting with me, they have to understand this part. Okay, you can just listen. Now, when it comes to R3, R3 is called as a two-dimensional model. R3 is what now it is? Two-dimensional, 2D. Do you know normalization concept? Any idea about normalization? So same thing, general, any RDBMS concept you take, right? Same concept, R3 is also like a, just like your normal RDBMS, you know, right? Normalization. So R3 is normalized. See? So R3 is what now it is a, we are saying two-dimensional model. That means, see what does that say? R3, okay, what is that now? Data is stored in the form of what? Table. How is data storing this in the form of? So a table consists of what? Rows and columns. Right. So now when you look at your R3 database, so how is that now it is going to store is like? In the form of a table. So let us say customer number, its name, address, and so imagine this is one dimension and this is another dimension. So this is what is called rows and this is what is called columns. Right, rows and what is that now? Every table will have, what is that called? Fields or anything you can call, what is that now? Fields or entities. Every table has what? Some fields or, so the header of the table, they are called as what? Field or, so what is the field now? Field defines physical existence of an object. Okay, what is a field is? It defines what? Physical existence of a, so customer number field defining the existence of, let us say C1. Name field defining the existence of AB. Address field defining the existence of Bangalore. Like that. Yeah. So field defines physical existence of a, so I can say the header of the table, like every column is one, every column has one field. Okay, every column is one field. This is what is all terminology I am discussing right now. And each row is what now? Each row is every column is a field and each row is called as what? A record. As of now I was saying 1000 records, means there are 1000 rows in that particular table. Okay? And without that I cannot define a table. Without that we cannot define a table. What is that? Every table will have what? Primary. So what is primary key? A primary key is one which is, yes, is one which is unique. So we can distinguish the data in the database with respect to what? Huh? With respect to a primary key. We can differentiate the data in the database with respect to what? So in order to distinguish the records in the database, you are going to use this. So now, if you look at this table, this value will not be repeated again. There may be two customers with the same name. There may be two people from the same address. Right? Bangalore. So there may be phone number also maybe. For two people it may be a same phone number. Let us say wife and husband. Right? So like that. So now, a unique identifier for a table is nothing but what? So like what is that now here? What is it? Customer. Clear? So now, let us say your employee ID, your bank account number, or let us say your telephone number. Is any other is having the same number? How you are distinguishing between the customers there? By a unique number assigned to you, right? Your sales order number, invoice number, right? Then let us say purchase document number or anything else. That's all. Yeah? Unique identifier. So that particular unique one is called as what now? So here in this table right now, what is your primary key? It is customer number, and the column which has the primary key is called as what? Is called as key column. The column which has the primary key is called as key column, and the rest are called as what? Non-key columns. Right? So the column which is having the primary key is the key column, and the other columns are called as non-key columns. And the one which is primary key is there, no? The field which is primary key that is called key field. Now, clear the terminology is clear? And now, how many fields can be a part of primary key? Is it only one? Can a table, can it have more than one field as a part of primary key? Only? Is it only one? Or will it allow more than one? So you are saying a table will have only one field as a part of primary key. How about you? So what is that now? Suppose, see this data and tell me which is a primary key now. Now let us say something called bill number. Okay? So with a bill, let us say I am buying some items. What is that now? Item number, and let us say what is that? Name of item. Okay? Now, bill number is, now what is primary key in this table? Bill number is primary key. Okay? Bill number is 1. With this I am buying an item called 10, and let us say what is that now? It is some table. Name. This is not quantity, this is the number of the item. Now, with a single bill, will you buy one product? It may be. So what is bill number now? 1. But what is the item that I am buying? So now, as I said, if it is a primary key, can it be repeated again? So now, is bill number is a primary key here? Then what is primary key? So as you said, now bill number is not primary key. What is primary key here? Item number. So come, let us say item number is primary key. Now second person, bill number is 2, but he is also buying item called. Then what is primary key here? Is it item number? So item number is also not a. Then what is it? Now, if you see what is the unit now, with a single field, now I cannot call it as a. I cannot determine the uniqueness. With a single field, can you determine the uniqueness here? No. Then what has to be done? So then, let us say, I will take a combination of these two fields as a part of primary key. Now, will 1 and 10 will repeat again? You may get 2 and 10, but not. Understand? So it's not that only one field should be a part of primary key. So like that, it may be more than one field also as a part of primary key. So when you have more than one field as a part of primary key, that is called as composite key. So like that, you can have any database you consider maximum of 16 fields as a part of primary key. Primary key is only one. It's not 16 primary keys, only one. But in this, the maximum number of composite key is like 16. That's why when I speak about BI, info cube, that we call it as a 16-dimensional structure. Normally, if you have some data warehouse, you can understand, we'll say like cube is a 16 dimension. Why? Because a database can have a maximum of 16 fields as a part of primary key. Clear now the terminology? What is primary key? What is composite key? And if you use primary key of one table in another table, if primary key of one table is taking part in another table, that is called as foreign key. If primary key of one table is used in another table, that is called relationship. Clear? The terminology is clear? Right. Now, come to the design. So now, when it comes to the design of your R3 database, the R3 database is designed based on a concept called what is that now? ER model. So which stands for entity relationship model. So ER model stands for what? The R3 database is designed based on a concept called entity relationship model. So any doubts with this now? What is ER model? Any idea about this? Sorry, not doubts. Any idea about ER model? So what you are doing, basically you are building the relationship between the entities. Fine. Why should I build the relationship between the entities? What you are going to do after building the relationship between the entities? Okay. Why and why? So what you are saying? So instead of storing the data in one single table, you are splitting the table based on the relationship. Why should I split? What happens if data is storing in one single table? Sorry? Why? Why it will occupy so much of space? Yeah, this is correct. It occupies so much of space. But why? Okay. So that means what is that word called? Redundancy. So that means same data is stored again and again into the database. That's why it takes more space. If you store into one table, that's why you are going to split it into. So now, what is ER model is here? What I'm saying, so any transaction is happening. Let us say we are creating one sales order. That is one transaction. Now, in R3, how it is stored now in the form of a table. No? So now what is it? See, any transaction takes place. Any transaction takes place. Now what is that now? This data will not be. This data will not be updated in a what? Single table. Right? Any transaction that takes place, this data will not be updated in a single table. And what is that? See now the transaction has been splitted. What is it now? The transaction has been. So how we are splitting is based on what? A relationship between the transaction has been splitted based on relationship between the, right? So I'm splitting the transaction. So as I said, what you are going to do by building the relationship between the entities is, this is used to what? Split your transaction. The transaction has been splitted and updated into what? Updated into multiple tables. For what now? In order to avoid, what is that now? In order to avoid redundancy. Clear? So, what is that now? Any transaction that is taking place, right? So this data will not be updated into. This data will not be updated into what? Single table. The transaction has been splitted and updated into multiple tables to avoid redundancy. That is what is your model says. Now suppose, so let us say, imagine my data is getting updated in one single table. Just observe what happens if your data is getting updated into one single. Now, let us say, imagine I have some table like this. I am just showing you a simple transaction. Huh? Okay, let us say what is that now? Imagine this is something called sales order number. So customer places your order. For every order you will be given some number. Then sales order number, let us say then name of person who has created this sales order. Then on what date it has been created. On what date it has been created. Then what is that now? Time of creation, and let us say value of what? Order. So that means what this order, what is the amount the customer has to pay me? The amount, right? Value of the order. Okay? And with the order, he places for some items. So let us say this is item number, then name of what? Item. Then how much quantity he is ordering for, and finally what? Value of order. This is with respect to what? So this is entire order value. This is item wise value. So let us say like this, sir. Imagine your data is storing in one single table. Now what happens? Suppose order number is 1. Imagine name of person is something, and the date it has been created is this, and the time it has been created is, and let us say the value of order is what now? 10,000. And imagine the item, what is going to order is item number 10. Now item 10 is nothing but like, let us say, some table. Then how much quantity is ordering is for? Right? 4 units. And 4 units means, let us say it is now what? Amount is what? 2,000. This is now entire order value is 10,000 with order 1 and item 10 values. So same way, order number is what now? With a single order, you can order for multiple items. So that means what happens? Order 1 is, what is this value now? It's created by ABC. Date is also same. Then item number is what? 20. Let us say this is some clear. Same way, order number is 1. So now, if you can observe, if you add these 3 values, 5 plus 3 is 8, 8 plus 2 is 10. So that is nothing but your entire order value. Entire order value is 10,000. But with order 1 and item 10 is value is 2,000. So like this, if you store the data now in one table, what is going to happen now? What is the problem? Same data, how many times it is updating now? So that means unnecessarily you are going to waste the space in the database. So that means it starts degrading your performance. It starts degrading your what? Performance. Right? So database performance is degraded. And now that's why what we are going to do. Now this is very simple transaction as shown. Let us say you have one order, 1,000 items are there. How many times it stores? 1,000 times. And let us say I have taken 1, 2, 3, 4 fields. Like that, imagine you have 100 fields. How many times it stores? So that is one transaction I am speaking about. Like that, how many number of transactions are there? So it starts degrading your database. So that's why we are not going to store now this data in one single table. Now I am going to split it. How I am going to split now? Based on relationship between the entities. Now, what is the relationship between these entities now? Let us say sales order number and name of person. Is one order is created by one person or multiple persons? That means, what is the relationship between this? 1 to 1 or 1 to many? One order is created by one person means it is 1 to 1. So relationship between this is what now? It's all. Then date of creation, time of creation, and what is that now? Value of order. All these are what? So sales order number to name of person, date of transaction, time. All these are what? One-to-one relationship. Now, next come to the other part like item number, the name of item. Item number and so what is the relationship now? One item will have one name, so that is it is. So same way the quantity, then the value of order with respect to item. This is also one-to-one. And what about this one? Sales order number and item number. One order, item 10, 20, 30. So how many items now? One order, multiple items. So that means it is what now? 1, 2. Now how is the data in this table? You have one set of one-to-one, there is another set of one-to-one, and there is one set of one-to-many. So what we'll do, all one-to-one relationship, we are going to let us say, we are going to split it into one table. This is all now one-to-one relationship. Okay. Next. Again, this is one-to-one. So this also will split it into a separate table. Now, what is one-to-many now? Order number and now what I'll do, the primary key of this table, that one-to-many, let us say we are going to take it in a sales order number. And what we'll be doing, we will be connecting now these two tables with primary key and foreign key relationship. Now how many times it is storing here? Now whenever it wants one, you have a connectivity now between these two tables. It will go and get the data from which table now? Understand now? So that's why when you look at your RPV database, any transaction takes place, it will not be getting updated into one single table. The transaction will be splitted and updated into multiple tables to avoid what? Redundancy. And one thing to be remembered, R3 is a ready-made application. It comes with ready-made application means ready-made database. That means ready-made tables. That means ready-made fields. R3 database is pre-designed. We are not going to design any R3 database. It's already designed. So it all comes with ready-made tables are there, ready-made fields are there. Everything is pre-designed. We just studied what was the design behind it. You are not going to design any database of R3. Understand the logic? So R3, everything is all ready-made tables are there, ready-made fields are there, everything is predefined. Clear? Now, if you store the data like this, where it is storing again and again redundantly, that is called as denormalized table. But when you store like this, where there is no redundancy, that is called as normalized. And what does that say? R3 is normalized. That's what we said, na? Data in the database for OLTP, that is for R3, we said it as normalized. Now R3 is optimal for what? Storage. What are the data that you are storing? It is optimized. Now, let us say if you are developing a report in R3. Now, what it has to do? It has to combine the data from two tables and it has to represent a report. How much time it takes? I have to combine the data from two tables and you want to represent as a report. Will it take longer time? So that means, that's why R3 is optimal for storage, not for analysis. That's why you are saying level of analysis is low. Understand the logic? So it is optimal for storage, not for. This is one reason why we don't develop report in R3, because it is normalized. So when you develop a report in R3, it has to integrate the data from multiple tables and it has to represent. Now can a top level management, can you wait for that much of time? So that's why what you will do while extracting data from R3 to BI side. So what I am going to do, we'll extract data from this table as well as this table and we'll put it into, let us say, one cube of BI. So even though it starts degrading database performance for me in BI, but for me what is very important? Analysis. Processing performances. So BI is optimal for analysis, not for storage. So BI is denormalized. So that means when I am extracting the data from R3, data from multiple sources, we'll put it into one location of BI. That is what is higher level of analysis you get. Where it is optimal for what? Optimal for what? BI is optimal for analysis, not for storage. Even though it degrades my database performance, but for me what is my maximum priority is analysis. That is why I understand now what is R3 database. Difference between R3 database and BI database is R3 is normalized, BI is denormalized. It's both contradictory. It is R3 is optimal for storage of your data, not for analysis of the data. Whereas when it comes to BI, it is optimal for what? Analysis, not for storage. Understand the logic now? So that's why when you look at your R3 database, so what are the data, what are the business that is happening? So this data will not be coming and storing in one single table of R3. It will be splitted and updated into multiple tables of R3. So R3 is optimal for storage. Fine. So today we are going to stop here.